All right, I guess I'm gonna go to YouTube and see if I can actually see it and hear myself. Let's see. I don't even know how. Hmm. Let's see. Maybe I can search. Just want to make sure the audio is actually working. Um, what if I go back to YouTube and I do what did I call it? C plus plus audio development. Let's write a portion full screen. Okay, here it is. Okay, I hear myself. All right. I guess we are good. Don't think I need this. Got my chat up, even though there's going to be nobody here. Okay, so like the title says, let's make a distortion. We started on the app already. Let me get it pulled up. And hopefully that is good. Yep. Okay. What do we have so far? I started making a channel strip. I think we've got a combo box with some oversampling stages in it. I implemented the oversampling logic, and I also showed you how to manage audio parameters with tree state with new updated method to actually use them. Okay, cool. Here's our app. Awesome. Looks amazing. So if we're going to start with DSP and do some distortion, let's go to the plugin processor and go all the way down to this section that says create editor. We don't really need our actual editor. We can do a generic one, which will give us sliders and buttons for the parameters that we put in the layout. So I can do new juice generic audio processor editor. And the only parameter we have right now is this, let's see here, the oversampling choice. So now when I hit play, it will go back to the ugly juice green background, and there will be one like combo box that is auto generated. So let's make sure that shows up. Perfect. So now we don't have to fool with the GUI until we are actually ready to. Okay, so let's just dive in. We already have a folder called DSP. We have our process block in there. So what should we do to keep this all organized? This is where all the DSP calls are going to be, where we process each one. So if we go into DSP and we do new directory and we say, I don't know, how about uh either blocks or modules or something. Maybe let's do modules, I guess. Okay. And in modules, we're going to create a header. And this is going to be, so we're making a channel strip. So we're going to have, like a kind of console input emulation. And then we're going to have, like EQ, compression, subtractive EQ, compression, tonal EQ, and then some kind of like master bus thing with crosstalk and maybe like a tape. Or we could put the tape in the input one. I don't know, it doesn't matter. So let's just call this input module. Or let's say console module. Cool. So we can get rid of this stuff and just use prog once. We don't need that header guard stuff. To get rid of this little warning right here, we need to go into the process block, which is where we're eventually going to call it. And we just need to put the include so that it sees it. And that's going to be in modules, console. I don't know why it's not auto completing. Console module. Let's see if it fixed it. Hmm. Because I didn't spell include correctly. What is going on? That's strange. There we go. Okay. So what do we need for this module? Basically, we need a prepare and a process method, at least. Let's wrap everything in a namespace to keep it nice and organized. Call it Viator DSP. Let's see. Yep, and then we'll make a class and we'll call it console. What I already forgot what I called it. Oh yeah, module. Console module. And for now, that's not gonna inherit from anything. We'll just do a basic class like this. Console module. I don't know if we're actually gonna need to do something with the constructor, so let's just do that. And then I don't think I really ever need a destructor for a DSP class. Give it a private section. Okay, cool. So we could do let's do a prepare method. I'm gonna kind of shy away from what I've been doing recently and go back to using just the juice process spec because I think it's just easier. And there's really no reason not to unless we get to that point and it causes a problem. We'll have to address it. So let's just call prepare. And this will take in a reference to let's see, I need juice DSP. And then we can do juice DSP process spec. We'll call it spec. Okay, not sure what we're doing with that yet, but let's move on to process block, which is going to take in a block. And I guess we'll also take in the number of samples. So let's do juice DSP audio block. Yep. Say float for now. Reference block. And then we'll do a constant num samples. Very good. Very good. Something else we could do. Yeah, since I am let's kind of set it up with templates because that'll follow the juice DSP modules um style and it'll allow us to do some SIMD optimization later whenever we're ready for it. So let's just go in and do that. Let's see. Let's just go to the juice modules and look at like the compressor or something. We got juice, DSP. The simple ones are in widgets. So we can even just look at gain. Mm-hmm. Yep. We just give it template type name. Float type seems like a bad name. Probably give it like sample type. Yes, 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 yes. This is interesting. I need to look up what this means. This might also be able to help us juice vector call type. I'm sure that does some kind of optimization. All right. And then we just do, yep. Okay, cool. So all we really need is this. template. And then anytime we want to use the template type, we pass in whatever name we give it, which for us is going to be, I think I'm going to do sample type. Yeah. Okay. And then that should mean that when we go to instantiate this, it will ask us for that type. So we do, nope, not juice, Viator DSP console module, and we'll pass it float, and then we'll say M console module. Let's make sure that builds. And then let me switch my camera real quick. I'm gonna take a look just in case there's somebody in the chat. Don't want to ignore them. Oh, there's people in the chat. What's up, everyone? Do you teach private lessons? I definitely can. I've done it before. Um, let me why don't you join the Discord? It will be in the description of the last 3 videos I just uploaded. So if you go to my Discord, you can message me and we can talk about that. Yeah. And thanks, F Beats. Oh, I'm glad I was actually helpful and you were able to learn some stuff. That's awesome. Nice. I only have one monitor, so I'm not I don't have the chat up on another monitor. Let's go back here. And our plugin built, so we are good. Looks like that template type name stuff worked. Cool, cool. All right. Let's actually do some stuff. To start, um, hmm, my phone's vibrating all the way in the back and I can hear it all the way from here. Let's let's see, where was I gonna go? I kind of want to kind of think about maybe also making a class called base module that every DSP module will inherit from, and it could have a couple of shared things like input, output, mix. Yeah, let's do that. Let's do base DSP module. Pragma. Once. Let's see, do we have to actually include it? I think we do. Let's do base module. Okay. Good. Okay. This probably will look funny at the beginning because there's only a couple of things we're going to put in here, but you know, it can grow. We can figure out if it's worth it or not and then discard it later. Base DSP module, which does not inherit from anything. Public default. Okie dokie. Now we could. I guess there's a bunch of things we could do. Let's just get those few. Yeah, in fact, I think we're gonna take a. I think we're gonna take this at the very least. Mm-hmm. And let's just this will be easy. Let's start with the smooth values. You're never gonna want to change any parameters. You know, on a sample by sample basis with just like a double or a float or something. You're gonna have zipper noise and stuff. So you want to use a smooth value for everything. But you need smooth values, one for each channel. Now, for the longest time, I always had a smooth value, and most of the time it would work, and then sometimes it just wouldn't work at all, and I was always confused. And it turns out that you can't reuse it among channels, so you got to have one for each channel. So we'll make an array of but to include that, we're gonna need I don't actually know which one we need. Um, one of the juice modules that will have um smooth value. I'm sure DSP will have everything in it. Let's just try it. Juice. Smooth value, sure. Okay. Float. And we're gonna have two. Because I doubt I'm ever gonna do anything more than stereo, especially for this. So let's do this one will be input smoothers. Then we'll have output smoothers and mix smoothers. Mm-hmm. Okay. Now this is pretty easy. We will just loop through each one. For auto smoother, or yeah, let's instead of let's do a regular for loop. So just so we could do it all in one loop instead of doing one loop for each. Let's just pick one of them, input smoothers dot size plus of I. So we'll say input smoothers I reset, which we need the sample rate and the ramp length. So we'll do spec dot sample rate. And then I usually do like 20 milliseconds. Yeah. Yes. Okay. And then we will do that for each of them. Let's see. Output mix. Okay. And let's see. What would make this actually useful? We would want, we could do, maybe it would be better to just, hmm. This is kind of the hardest part, trying to figure out if your idea is actually going to be useful or if you're just doing a whole bunch of extra stuff. I don't even know how to think about this out loud. I'm just we need a process block, but we also need a like a process sample that'll be a sample by sample. I'm trying to think if it would be better to have a process sample method that's virtual that we have to implement, or because I want all this stuff taken care of without having to do it in every single class. So maybe, hmm. Well, let's just write and see where it takes us. Let's say process sample. Yeah. Okay. I think what we're gonna want to do is that. So let's do virtual void process sample equal to 0. So we're forced to implement it. And what we will do is just loop through. And I got some code snippets saved. So let me pull that out. Boom, a block loop. So we're looping through each channel of the block, and then we're looping through each sample. So what we want to do, oh, this is virtual float, by the way, because we're going to return a float. Because what we're going to do is this. xn, which is our input. We're going to say yn, which is our output, is equal to process sample xn. So this needs to take in a float, I think. Okay. It's const qualified function. Okay. So yeah, when we implement it, we'll put the const in there. Okay. And then I guess the last thing we want to do is access each one of these. So we will, hmm, this may not all even be necessary, but let's just do it. We could return an array. Yeah, we can just return the array that we want. So, um, get inputs, which will return, I think we could just do it like this, right? Input smoothers. That should be legal. Yeah, okay. So let's just do that for each one. Get inputs, get outputs, and mixes. Okay. Output mixes. Okay. So that's cool, I guess. Oh, I'll put I'll put a new link up somewhere. I'll probably put it in the description. So let me get back here. Sorry, I messed that up. The smoothers. So what they do is, um, it's actually easier to demonstrate, but basically, they will, when you call get next value, it will interpolate between values so that fine, there's more fine, um, what word am I looking for? Um, like instead of going from like point 1 to point 2, it'll go from point 1 to point 101, 102, like over time. So it's a smoother transition. Whereas if you just have a float and it's attached to a dial, if it's at like 5 and you take the dial and you turn it quick, it'll basically go to 10 or whatever instantly, which is a really hard cut. But with a smooth, it will see the turn, it knows what the target is, and it'll take its current value and slowly ramp up to that target. So it sounds better. No clicks and stuff. Yeah, okay. Cool. So this is pretty simple. I actually found something good. I did a lot of research in chaotic equations when I was in grad school. And if I go to Desmos here, I'll show you. And also if I do list of chaotic maps, this one right here. I took one of these and I just found one that's a simple discrete one, like this one, the circle map. And I just took its equation and since it's one dimensional, I just plug in anywhere it says O of I, I'll just plug in our input there. And yeah, it's pretty simple. I'll show you on Desmos. So the equation is, xn plus omega plus k divided by 2 pi times sine of 2 pi x. And this is what we get. I already saved it over here. Where is it at? Circle map distortion. Okay, here we go. X plus k divided by 2 pi times sine 2 pi x. And you can see when k is 0, our signal is perfect. It's not distorted in any way. It's a perfect sine wave. And as we raise this, it gets distorted. And this was a cool find. Um, it also sounds a little compressed. So you can see where it flattens out right here and then goes back up. that gives it like a kind of compressed sound. And if you go negative, it does a different shape, which looks interesting, but it actually doesn't sound great. And I tried it out a lot on some like drum material and some kind of melodic material, and I just couldn't get it to you know, sound good for whatever reason. So I'm just sticking with this because it actually sounds good and distorted and warm and a little compressed. So it kind of models tape a little bit. So yeah, here's the equation. We're just gonna plug that in. The only annoying part is I talked about a minute ago that we might want to try to implement the SIMD optimization stuff. And with a sine function, we can't really do that. So if I do end up figuring it out, or if I do end up wanting to do that, we'll have to figure out how to SIMDify the sine or accomplish this without a sine function. But it doesn't matter. It's not like this is really high CPU usage anyway. So let's just implement it. So we are going to say float get, I don't know. We can just say get distortion. That will be float input. And this is pretty simple. But before we just plug in the equation, we need one thing. Let's grab 2 pi and put that into a variable because we don't need to calculate that every sample. We know what 2 pi is. So let's go here and we'll say static const expr float. And we're gonna say um 2 pi equal to juice. Let's see, math constants float. And you go into it and there's a pi. So and then almost forgot, multiply by 2. Okay, cool. There we got 2 pi. Great. So let's do this. Return input. Already forgot. Plus. Oh yeah, we need like a drive, like a K. Okay. So let's do that. Um let's do let's do a smooth value. So we'll do this. I think we only need one. So this will, instead of input, I'm gonna call this drive. Cool. And then we can just do this. For auto um drive in, drive smoothers, drive dot reset, spec dot sample rate, and let's just give it 20 milliseconds. Okay. Hmm. You know what? We don't really need to make a, yeah, let's not even make a separate function. This is small enough that we can just do it in the process block. There's really no reason to break it out. So let me grab a block loop and we're going to plug it in right here. Xn is equal, or I'm sorry, Yn, which is usually output. Like if you're looking at any kind of scientific paper or math paper or engineering paper, usually input is Xn and output is Yn. So yeah, so we already got Xn. So Xn plus, and then let's get our drive. So let's make a variable up here, float drive, or we could just call it K like it is in the equation. And we're going to say M drive smoothers. And we have 2 for 2 channels. So let's use channel as the index and then get next value. That's what gives you the current smooth value. And I'll show you how to set it in a second. So this is going to be K divided by 2 pi times STD sine. And that's Xn times 2 pi, right? Plus, it looks good to me. Okay. That's it. All right. So let's just make a setter real quick. So we're gonna do void set drive. We'll take in a const float. And all we need to do is loop through the smoothers and call set target value. And that's in decibels. So we're gonna need to do this. Juice decibels, decibels to gain, and then value. Pretty easy. Cool. So when you call set target value, it will tell it to start ramping up to that target. And that will be it. My alarm is going off. Look at chat real quick. Oh wow, what's up everybody? I really did not expect people to be in here. That's crazy. Yeah, it avoids glitches and from abrupt changes. Yeah, it's perfect. That's way better than the way I said it. So now we just need to actually put this in our process block. So let's go here. And yeah, okay. I think we are good. So we're going to say m console module dot prepare, and we'll pass it this spec that is already upsampled, because in our processor we have 5 versions of this process block, one for no oversampling, one for 2 times, 4 times, 8 times, and 16 times. So whenever you write something in here, that the switching is taken care of outside of it, so you don't need to worry about it. And this repo is on my GitHub, by the way, so you can all download it, and I will push changes at the end of the stream. So prepare, then we call process with this upsampled block, and that will upsample if we're on the upsampled one. Oh, and we also need to pass it num samples. Now, did I actually use num samples? Let's see. Yes, I did. Okay. Now you're gonna want to pass num samples to your uh DSP modules, because some DAWs, especially FL, does this weird thing where it could randomly just give you a like 2 sample block for no reason. And if you're always relying on basically like an alias block that isn't in our main process block, like in the plugin processor, you're gonna get weird clicks and distortion and stuff. So I've been just doing this as a um you know, no matter what. Okay. And we need to call set drive, and that will be it. So where do we do that? In process block? And we don't have a parameter for it yet, so let's go up here. Let's copy these. This will be console drive. And I will just copy the names into here. Cool. All right. So we make another parameter, and this is the cool new way, not new way, but best practice way to use parameters now, because using the get raw string lookup apparently can be really slow. So if you just set a pointer pointing to the parameter at the start, and you just use that pointer, it's much faster. And we do this right here. Console drive, float, and ID. I mean, it is a little annoying having to do things in 2 spots, because we still have to go into the processor and put it in the here in the layout, but You know, it's fine. So this is float, and this is I already forgot. Console drive, console name, and this is not a choice. Oh, what we got here? Console drive, console drive. Oh yeah, because I just didn't fill this out yet. Okay. So we need a normalizable range, which drive usually go from. Oh, this one is 0 to 1, but 0 to 1 as a drive will sound funny. So let's make it 0 to 10, and then we just scale it in the module, and it will default to 0. Yes. So okay. So now process block. Now we go. We need. Yes, we need a update method. Update parameters. And this needs to take in our parameter thing right here. Where's it at? This, which I already forgot the type. Oh, the type is right here. Vitor. Yes. Okay. So we need to take a reference to that, I think. Call it parameters. Is that fine? Yeah. Okay. And then we would do this console module, set drive, parameters. Here's the cool part about the pointer. We'll do dot console drive, and we just do the pointer dot, and we do get, and that gives us our float value, and without using a string lookup. But remember, this is 0 to 10, so we need to multiply it by 0.1, and that should give us 0 to 1. Cool. All right, let's build and make sure it doesn't crash, and then I think we should be able to test it. I'm not sure what I'm gonna do about a second monitor. I have a second monitor in a box, but I just like having one so much because I don't know, it just helps me focus, I guess. I don't know. What did I miss? Uh oh, I also don't have a massive amount of space on my desk. All right, doesn't crash and it lets me do that. Okay, cool. One thing I'm going to change is cuz I know it's going to bother me. Go into parameters here. We're going to change this to console drive. Okay, let's see. Let me check. What's up, everybody? Hope you're enjoying. It's been so long since I've done this. It feels kind of dumb hearing myself talk. All right, so that worked. So let's build it, and then we can test it and plug in Doctor. Just to make sure it's actually doing what we want it to do, because I don't want to open it in Logic and then all of a sudden have like a loss value of 10,000 screaming at me. All right, so that should be fine. Let's see. We'll go here, go to plugins. I'm not gonna actually open the folder because I have some client stuff in there. Maybe I didn't think about that. All right, projects, VTorque. Nope, that's the other VTorque channel. Comment strip. Okay, so inside CMake build debug, artifacts, debug, AU, that. Okay, just drag it to components. All right, let's see here. Let's see. Oh, we got silence. This is no good. Let's see. Did I just do something dumb? Did I mute the buffer or something? I did. I don't even remember why. All right, reset. By the way, I didn't know this, but Sea Lion is free for non-commercial use. So you can all go ahead and download it if you want. Components. Oh, classic. Okay. This is just a plugin doctor error every once in a while. What you need to do is just delete the debug folder and rebuild. Should be good. Comment. Brother. I don't understand why it does this sometimes. You know what? Go in here. I'm going to delete all of my plugins. Okay. I'm going to delete the artifacts folder. So this should be super fresh. And if it does it again, I'm going to lose my mind. I'm pretty sure it's fine. I could test it in Logic, but let's see here. Where's it at? Oh, artifacts. Debug. AU. Let me just copy it instead of moving it. There we go. All right. Let's look at the oscilloscope. Let's see here. Let's see if it looks the same way it did in Desmos. Oof. Not good. Probably just another stupid mistake. Drive smoothers. Hmm. Oh, because it's not decibels. I forgot. This isn't a normal drive. This is going to be 0 to 1. So I guess we just need to pass in value. Yep, that's what it is. Yeah, the first time I tried VS Code with CMake, I lost my mind and I was doing it for like 2 or 3 hours. But the last time when I made the first video last week, it actually worked surprisingly well. I don't know if I mean all it did was like a simple build and ran it with the standalone and it worked fine, but I don't know. I like having an actual IDE to, debug and stuff. Let's see what we got here. Put that in there. Oh, it's still not doing anything. You're 10. Okay, so let's do this. Let's make sure. Let's debug this K value. I'm sure it's gonna be something just really dumb. 0, 0. Okay, so it's just not actually getting anything. Process block. Oh, I know what it is. I know what it is. We need to call parameter change. Okay, so I think we could just take the same pattern, right? And update parameters. So oversampling choice and oversampling choice, blah 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 blah. Instead of calling process, we're gonna call what is it? Update parameter, and then this is gonna be m parameters. But we got to dereference it, right? Because it's a smart pointer. Yeah. Okay. All right. So let's just run it one more time to make sure that little debug thing is printing out the numbers we expect. 0, 1. Perfect. All right, so we can take this out. Build. Okay. There we go. It's going to work this time. I feel it in my bones. Yep, look at that. All right. Cool. Now, let's see what it sounds like. I actually forgot to think about setting up logic with wavelength stream. Let me see. Not that big a deal to set up, I guess. I just don't want it screaming in your ears. Let's new project. And then let's get some drums. Let's see, where's there we go. 60s shuffle drum set, a classic. So what I want to do is settings audio output, make it uh wouldn't it be a wavelength stream? I could do black hole. And then I just have to open up wavelength and make another input. And I don't even know. I'll just say gain. Okay. And I'm gonna turn this down. And I'm gonna loop this. I really hope that's not screaming in your ears. I'm gonna turn it down just in case it is. Oh, let's see where we at. Wavelength right here. Doesn't look like that's coming through. I wonder if I might not need to actually change it to black hole. I might be able to leave it as. Oh, look, now I have wavelength stream as an option. Okay. Okay. I don't think it's coming through. It would need to be this slider. And if it was actually working, it would be here. So go back and we'll do again, and we'll do logic, maybe. Nope, it don't want. Oh, that was the input. Let's see. Let's change this back to black hole and output. We'll do. I don't understand why it doesn't let me pick wavelength.